The increase in the dimension of the body with the increase in temperature is called thermal expansion of a solid. Isothermal process can be called as V is inversely proportional to the pressure at constant temperature, which means to say it's same as that of your Boyle's law. It's a heat capacity, means it's amount of heat required to raise the temperature of certain amount of substance by 1 Kelvin. Hello everyone, I'm Vrinda from Department of Physics. Today we are dealing with chapter 11, that is thermal properties of matter. From this chapter we can see that the complete chapter is all about your heat, temperature, all these concepts. So as you all can see, there is a water which is boiling and the temperature has been noted down. So there is a difference between heat and temperature, students. Heat is nothing but it is a sensation whether hot or cold it is. But what is a temperature? Temperature is the one which measures the hotness or coldness of the body. That is what you have to keep it in your mind. Temperature is a measure of hotness or coldness of the matter, and its SI unit, in what terms it is being measured? It is being measured with the instrument called as thermometer. Thermometer can be of Celsius, Kelvin as well as Fahrenheit scale, wherein you measure with respect to the Kelvin scale, and our body temperature will be measured in case of your Fahrenheit scale. So that one you will have to remember. Heat is a form of energy transformation between two of the bodies, that is just the sensation. So the SI unit of heat is said to be the joule, okay? And measurement of temperature is with respect to the thermometer, as you all can see here. So thermometer is an instrument which is used to measure the temperature of a body. So there are types, that is Celsius scale, Fahrenheit scale, Kelvin scale and all. So for this, in order to convert Celsius to Kelvin scale, there is a equation, that is T in degrees Celsius is equal to 273.15 plus whichever value you have in case of degrees Celsius, you will have to apply it so that you get a value of temperature over here, okay? Next, we are having absolute scale of a temperature. So what is the absolute scale of a temperature? At a constant volume of a gas, the thermometer is used. Okay, when a constant volume gas, thermometer is used, and the volume of a gas is kept constant, and the change in pressure of the gas is used to determine the temperature, which shows that pressure in the bath varies linearly with the critical temperature. So, as the temperature increases, the pressure increases is what is being shown over here in the graphical representation, which means to say on extension of the same linear line towards backwards, that is negative axis, you get one value, that is minus 273 degrees Celsius. That value is called as absolute scale of a temperature. Straight line is extrapolated, as you can see, okay, that is this value is what we are getting. At this temperature, the pressure of the given mass of a gas becomes zero, is what they are telling, at a constant volume. So such kind of a concept is called as absolute zero or a absolute scale of a temperature. Next, we are moving on to thermal expansion in solids. So what is this thermal expansion in solids? Solid, the one in which the molecules are tightly packed or closely held. So to increase in the dimension, that means if you want to increase or decrease the dimensions of certain bodies, the temperature is given to it. So the increase in the dimension of the body with the increase in temperature is called thermal expansion of a solid. You can see as you heat it, what happens? There is the cold metal ball, it can pass through the ring before that is before heating at room temperature, as given in this caption. Suppose you start heating the same metal ball and start leaving towards the ring, the ball gets expanded due to the temperature increase, okay? So that is what we actually see here, thermal expansion in solid. Next, we have types of thermal expansion in case of the solid, that is, one is linear expansion, one is area expansion. Linear expansion means the increase in the length of the body as you increase the temperature. Very easy. The heading itself gives you linear expansion. What is the expansion? The change in its length, dimension or configurations. So now the increase in the length as the temperature increases is called as linear expansion. Similar way, area expansion means increase in the area of the body with increase in temperature is known as area expansion. So with respect to this, we have got the coefficient of its linear expansion and coefficient of area expansion as well as coefficient of volume expansion. Increase in the length per unit rise in its temperature is called as linear coefficient of linear. Increase in its area per unit rise in its temperature, that is called as your coefficient of area expansion. Similar way with respect to volume expansion, certain small increase in the volume per unit rise in its temperature is called as your coefficient of volume expansion. So these are all about the set of expansion what we study with respect to solids. Similarly, you can see the set of this expansion in case of solids, that is when the temperature is increased practically. So practically we have the rails on the railway tracks. Small spaces will be left in the railway tracks. So that is due to, because in summer when the temperature increases, what happens? The rail tracks gets attached. So they need some space. Otherwise it will overlap with each other. That is what exactly they have looked after. Next is telegraphic wires and electric transmission wires. They are hung down because during winter it has got the contraction. That is why it is hung down. So hot water can be poured into metal cap of the bottle so that the cap expands. So all these are the concepts, that is the practical effects of the expansion of a solid. Next we are going to thermal expansion in case of liquids. So there are two types of thermal expansion. One is real as well as one is apparent expansion. As you can see here, the liquid expands when heated, when less heat is produced as well as when more heat is produced over here. So having this expansion of liquids, we shall explain about the anomalous expansion of water. What exactly is anomalous expansion of water? As you can see here, the aquatic animals which is within the water, that is the ice water. So how exactly we define this anomalous expansion of the water? Consider a superficial area of a lake, that is the surface area of the lake. Suppose there is a superficial layer here and it is a winter season. What happens? The body object which is over the top of the lake gets cooled down. As it cools down, its density increases. When its density increases, its volume decreases. This is decrease in volume. This is increase in density. When the density increases, the layer shifts downwards and the layer which is over here transfers above. And again, the layer which is below the superficial layer is a little bit warmer. So as it travels up, again it starts cooling down to some certain degree Celsius and its density increases, again it sinks down. So again one more layer comes up. Similarly, each and every layer cools down, sinks, cools down and sinks. So this format, and finally there is a last layer which actually have to come up, and the last layer cools down to certain degree Celsius, that is 0 degree Celsius, and forms the ice above the top. Above, okay, maybe in your ice places or ice regions and all, it forms a layer of ice at the top. So the below there is a space, or the below the temperature is maintained so that aquatic animals can live freely. So this concept is called as anomalous expansion of water, and this is one of the main concepts in an exam point of view. So you'll have to know what is anomalous expansion of water. Next is isothermal process. Isothermal means isolated temperature. The temperature is said to be the constant one. So isothermal process, it's a process in which the changes in volume takes place as well as the pressure of the gas, but it is happening at constant temperature. So temperature is said to be constant over here. So isothermal process can be called as V is inversely proportional to the pressure at constant temperature, which means to say it's same as that of your Boyle's law. So you have your variations inversely proportional. So you have your pressure and volume. So as the volume increases, your pressure decreases. So this can be curve of your isothermal process at which temperature is constant. Heading itself you will know constant temperature concept. Okay. Next we are going to adiabatic process. So here you can see Adiabatic process in which the volume and pressure takes place in a complete thermal isolation with the surrounding. In case of adiabatic process, you will not have any changes with the heat as well, heat of the body with respect to the surrounding. It is isolated from the heat which passes from the surrounding to the object. So such kind of a process is called as adiabatic process. Specific heat capacity. It's a heat capacity means it's amount of heat required to raise the temperature of certain amount of substance by 1 Kelvin. So specific heat capacity means quantity of heat required to raise the temperature of unit mass of a substance through unit Kelvin. That means 1 Kelvin. Okay, that is called as your specific heat capacity. So we have molar specific heat capacity definition also, which means to say the heat which is required to raise the temperature of 1 mole, molar specific heat capacity, no? So it is 1 mole of the substance temperature is raised by giving up the heat through 1 Kelvin is called as your molar specific heat capacity. And plain heat capacity in a normal way, just heat capacity means raise the temperature of certain quantity of substance by 1 Kelvin. So in case of specific heat capacity, we have two types of capacities, that is specific heat capacity at constant volume and specific heat capacity at constant pressure. So heat required to raise the temperature of 1 mole of a substance by 1 Kelvin at constant volume is called as specific heat capacity at constant volume, and heat required to raise the temperature of 1 mole of a substance by 1 Kelvin at constant pressure is called as specific heat capacity at constant pressure. So this can be called as CV and this is called as CP. So here the specific heat capacity at constant volume is done, specific heat capacity of constant pressure is done. So this is all about specific heat capacity concepts. So in today's class we have dealt with thermal properties of matter chapter. Let us all meet in our upcoming session. Until then, have a good day. Thank you.